possible universe. What if the universe was never meant to exist? Not metaphorically, not poetically, literally. According to modern physics, every law of nature, from gravity to quantum mechanics, says the same thing. The universe should not be here. After the Big Bang, matter and antimatter annihilated each other completely. Every particle that existed was instantly destroyed by its twin. Everything gone. But something impossible happened. Out of every billion particles, one survived. That tiny imbalance, 1 in a billion, is the reason you exist. It's why the stars shine, why galaxies form, why there's anything at all. But here's the question no one can answer. Who or what decided that one should survive? Is it luck, or is the universe cheating its own rules? If the laws of physics are perfect, then the fact that you are alive means that something somewhere broke them. And maybe that's the reason the universe is so strange, because it was never supposed to happen in the first place. The perfect balance that should have broken. After the Big Bang, the universe balanced on a razor's edge. Matter and antimatter existed in perfect equality, like a mirror facing itself. Two identical twins destined to destroy each other. But somehow, one side won. A microscopic bias, smaller than imagination, tilted the balance. We don't know why. We just know that without it, there would be nothing. If even one law of physics had been slightly more precise, the universe would have collapsed back into silence before it even began. So what broke the symmetry? A quantum fluctuation? A design? Or, as some physicists whisper, was the imbalance inserted into the system? This is where science meets discomfort, because the math says it shouldn't have happened. Yet everything, you, me, galaxies, atoms, is built from that violation. So ask yourself, if existence itself is born from imbalance, is perfection really what sustains the universe, or what almost destroyed it? The fine-tuned forces. Gravity, electromagnetism, strong and weak nuclear forces. 4 fundamental forces hold everything together, but they're too perfect, so perfectly balanced that even a microscopic change, 1 part in 10 million, would make the universe fall apart. If gravity were just slightly stronger, the universe would collapse before stars could form. If it were weaker, matter would scatter into infinite nothingness. But here we are, in the one version of reality where the constants are just right. Coincidence? Or something else? This is the fine-tuning problem. The deeper scientists look, the more precise the universe seems. And the more precise it seems, the less likely it becomes that it's random. So, who calibrated reality? Was it luck? An infinite cosmic lottery that we just happen to win? Or does the universe know how to balance itself? Because if the universe can self-tune, then maybe it's not a machine, maybe it's a musician, playing the melody of existence. the fragile birth of light. Before there was light, there was silence, a black ocean without a single flicker. For 380,000 years after the Big Bang, the universe was blind. Then, something extraordinary happened. Atoms began to form. Hydrogen fused with helium, and suddenly, the first stars ignited. Light tore through darkness. It wasn't gentle. It was violent, raw, a scream of creation across the void. But here's the paradox. If the early universe had been just a little denser, light would never have escaped. And if it were thinner, stars would never have formed. So once again, it balanced perfectly between existence and nothingness. Some scientists say that light didn't just illuminate the universe, it defined it. Before light, there was no structure, no form, only potential. Light was the first choice the universe ever made. And from that choice came everything. So maybe when we study light, we're not just studying physics. We're studying the universe, remembering how to live. The cosmic coincidences. Everything about our world seems too convenient. The sun burns at the perfect temperature. Earth orbits at the perfect distance. Our galaxy spins slow enough to be stable, but fast enough to create stars. How many coincidences does it take before something stops being coincidence? Astronomers call it cosmic fine-tuning. Philosophers call it design, but maybe it's neither. Maybe the universe isn't fine-tuned for us. Maybe we are fine-tuned to it. Because here's the uncomfortable truth. If even one of those cosmic parameters changed by less than the width of a human hair, we wouldn't exist to notice. So are we lucky or inevitable? Is life a miracle? Or just what happens when the universe gets bored of chaos? And if the universe made us just to look back at it, who's really watching who? The multiverse hypothesis. Here's where things get uncomfortable, because maybe our universe isn't unique. Maybe it's not even special. The multiverse theory says there could be infinite universes, each one with different laws of physics, different constants, different possibilities. In one, gravity might crush everything. In another, atoms might never exist. And in a rare, almost impossible one, everything works just right. Ours. So if that's true, then maybe there's nothing miraculous about our existence. We just happen to live in the one that survived. But there's a catch. If infinite universes exist, then somewhere, another you is watching this video right now, in a world where everything turned out slightly different. Scary? Maybe. But also strangely beautiful. Because even if there are infinite possibilities, you still ended up here, in this one. The anthropic principle. Why does the universe seem perfectly designed for life? Maybe because it had to be. According to the anthropic principle, we see a universe that allows life, because if it didn't, we wouldn't be here to see it. Simple, yet deeply unsettling. It suggests that everything, from gravity to starlight, exists not just by chance, but because the cosmos somehow expected us. Did the universe create observers just to confirm its own existence? Did reality need witnesses to become real? It's a scientific idea, but it sounds almost spiritual. And it raises a dangerous question. If the universe needs to be seen to exist, then what happens when no one is left to look? The quantum lottery. At the smallest scale of reality, nothing is stable. Particles appear and vanish. Energy flickers like static. The laws of physics roll dice over and over again. Quantum mechanics says reality isn't fixed until it's observed. So who or what made the first observation? Did consciousness collapse the universe into being? Or did the universe collapse consciousness into us? Maybe both are true. We think of randomness as chaos. But what if randomness is creation? A billion chances, all failing, until one finally becomes a world like ours. We are that impossible result. The winning number in a game the universe didn't plan to play. And if everything is chance, then even awareness, even love, thought, and curiosity are quantum miracles. The universe that shouldn't exist. Maybe the universe doesn't follow the rules. Maybe it is the rule. From nothing came something. From chaos, order. From silence, light. And from lifeless matter, you. Science says it shouldn't have happened. Entropy says it should have fallen apart. Yet here we are, talking, thinking, existing. So maybe existence isn't a fluke. Maybe it's rebellion, a quiet defiance against the void. Every galaxy, every atom, every thought, a whisper saying, I refuse not to be. And when the last star fades, when everything returns to darkness, perhaps one spark will still remain, because the universe remembers what it means to live. Maybe that's what we are, the universe becoming aware of itself, refusing to disappear. The cosmic lie. What science doesn't want you to know about the universe. For centuries, humanity has looked to the stars searching for truth. We have built telescopes, launched probes, written equations that stretch across chalkboards and fill entire libraries. Scientists assure us that with each discovery, we are getting closer to the ultimate understanding of the universe. But what if that is not true? What if science is not revealing reality, but hiding it? Think about it. 95% of the universe, according to modern physics, is invisible. They call it dark matter and dark energy. Words that mean nothing more than, we don't know. Scientists admit openly they have no clue what fills the vast majority of existence. And yet they continue to speak with authority, as if they were custodians of truth. What if science is not about finding truth at all? What if it is about creating stories that sound convincing, models that make us feel safe, lies that comfort us? When a strange signal echoes from the depths of space, they tell us it must be a dying star, or a magnetic field, or some phenomenon they can name. When a black hole flares unpredictably, they invent new theories to explain it away. When a comet enters our solar system from interstellar space with bizarre shape and unexplained trajectory, they insist it is just a rock because the alternative is too dangerous to admit. Science offers explanations, but explanations are not always truth. So tonight, we will look into the mysteries that defy their charts and equations. We will confront the signals, the shadows, the particles, the forces, and the visitors that science cannot explain. And we will ask the questions they fear the most, because maybe, just maybe, the universe is not the neat, ordered machine they describe in textbooks. Maybe it is stranger, darker, and far more unsettling. Maybe the biggest lie of all is that they understand it. What do you think? Is science uncovering reality, or just telling us stories? Strange signals from space. In 2007, astronomers detected something that should not exist. Powerful bursts of radio waves arriving from galaxies billions of light years away. They lasted only milliseconds, but in that brief moment, they released more energy than our sun emits in several days. They called them fast radio bursts, FRBs. The first time, scientists thought it must be an error, a glitch in the telescope. Then came another burst, and another. Soon, hundreds had been detected, coming from across the sky with no clear source. Explanations multiplied. Some said they came from collapsing stars, others from magnetars, exotic neutron stars with powerful magnetic fields. A few even whispered the possibility of colliding black holes. But none of these theories fit the repeating signals. Yes, some of these bursts repeat. The same cosmic source sending multiple pulses, like echoes in the dark. And here is the thought that scientists hate to hear. What if these are not natural at all? What if these bursts are transmissions, messages knocking on our cosmic door? Science avoids that idea. They prefer a collapsing star, even when the data does not fit. But deep down, you have to wonder, why are we so afraid to consider the possibility of intelligence out there? Black hole mysteries. Black holes are supposed to be simple. They are described as cosmic drains, swallowing matter, light, and time itself. According to theory, once you fall in, nothing escapes. End of story. But reality is not so obedient. At the center of our galaxy lies Sagittarius A*. For decades, it was thought to be quiet, a sleeping monster. And then, without warning, it flared. A sudden, massive burst of energy, 100 tons brighter than normal. No theory predicted it. No one could explain why. And then there is Hawking radiation, the idea that black holes slowly evaporate over trillions of years, leaking particles at the edge of their event horizons. A brilliant concept, but one that has never been observed. So what are black holes really? Are they monsters of gravity? Gateways to other universes? Or proof that our understanding of physics is still fundamentally flawed? What if black holes do not exist at all? What if what we call black holes are simply artifacts of broken equations, illusions created by the limits of our models? If that were true, then entire branches of physics would collapse overnight. Cosmic rays and high-energy mysteries. Every day, Earth is bombarded by cosmic rays, high-energy particles from space traveling at nearly the speed of light. Most are harmless, ordinary protons or nuclei. But a few are anything but ordinary. Astronomers have detected particles with energy so extreme that they defy logic. We call them ultra-high energy cosmic rays. A single proton slamming into our atmosphere with the energy of a baseball pitch, carried across the universe by no known source. Scientists reassure us. It must be natural, but is it? Why do we insist on calling something natural just because we cannot explain it? Maybe these cosmic bullets are not accidents. Maybe they are not from stars at all. Maybe they are something else entirely. Something or someone sending us a message in the form of impossible energy. The dark fabric of lies. The universe, we are told, is well understood. Galaxies spin, stars are born and die. Gravity rules all. And yet, when astronomers measured the movement of galaxies, something didn't fit. The stars were moving too fast, the galaxies holding together too strongly. According to visible matter, they should fly apart like sand in the wind. According to physics, no star, no galaxy, no known event can accelerate a particle to that level. And yet, they exist. So what did scientists do? They invented something invisible. They called it dark matter, a hidden substance, undetectable, invisible, making up most of the mass in the universe. But that wasn't enough. When they looked deeper, they realized the entire cosmos is expanding faster than it should. Something was pushing galaxies apart, faster and faster. Another invention, dark energy. Today, they claim that 95% of the universe is made of these unseen, unmeasured things. And yet, they have never captured a particle of dark matter, never measured dark energy directly. What if these things don't exist at all? What if dark matter and dark energy are simply placeholders for our ignorance? Convenient lies that let scientists continue publishing papers while admitting they have no idea what the universe is made of. Would you trust a doctor who tells you he understands your body and then admits he has no clue what's inside 95% of it? That is the state of modern cosmology. The visitors we pretend are rocks. Oumuamua, Borisov, Atlas. Three names that should have shaken the foundations of science. In 2017, astronomers spotted a strange object hurtling through our solar system. Oumuamua. It was long, cigar-shaped, tumbling, and moving in ways that didn't match any comet or asteroid we had ever seen. Some scientists dared to suggest it might even be artificial. Most dismissed the idea quickly. Too dangerous, too disruptive. Then came 2I Borisov in 2019, a true interstellar comet moving at impossible speed, with a chemical makeup different from any other comet in our skies. Proof that interstellar visitors are real. And then 3I Atlas, fragmented, strange, behaving in ways no ordinary rock should. Were these just chunks of ice and dust wandering through space? Or were they scouts, probes, technology from elsewhere? If one of these really were artificial, do you think the scientific establishment would admit it? Or would they bury the truth, wrap it in the comfort of words like asteroid and comet, and tell us to move on? The patterns in the chaos. Step back and look at the universe. Galaxies spinning, stars orbiting, planets turning, atoms themselves in constant motion. Everything spins, everything rotates, everything dances in patterns. Why? According to physics, it is momentum, gravity, conservation of energy. But deep down, there is something uncanny about the order. Why does chaos produce such balance? Why does randomness create such elegance? Perhaps there is a hidden structure we cannot see, a deeper law, a cosmic code embedded in the fabric of reality. Order is not natural. Order is designed. If you see a clock, you do not assume it assembled itself from dust. If you see a spiral galaxy, should you assume it did? Maybe the patterns in the chaos are not accidents. Maybe they are signs. Signs of something greater, something deliberate, something intelligence does not dare to admit. Beyond the edge of theories, science thrives on confidence. Equations on chalkboards, simulations on supercomputers, diagrams that make it all look neat. But look closer, and you'll see cracks. Quantum physics says particles can be in two places at once. Relativity says nothing can move faster than light. And yet, observations sometimes hint otherwise. Theories that should fit together do not. They collide like mismatched puzzle pieces. Physicists chase a theory of everything, a single framework that explains it all. String theory, loop quantum gravity, multiverse models, elegant on paper, but unproven in reality. What if there is no final theory? What if reality itself cannot be captured in equations? Maybe science is not about truth. Maybe it is about comfort. Maybe the universe is stranger, darker, more intelligent, more alive than we dare to believe. And maybe the real story of the cosmos is only just beginning. Why Saturn is the scariest planet in the solar system. Listen carefully. That sound is not cinematic decoration. That is Saturn. Not music, not a sound effect. A planet broadcasting raw radio emissions into space, like a warning no one was supposed to hear. For centuries, Saturn looked harmless from a distance. Elegant, symmetrical, glowing. A golden giant wrapped in perfect rings, floating in silence like a masterpiece. And that is exactly why it is so dangerous. Because Saturn does not look like a threat. It looks like beauty. But in space, beauty can be a disguise. Saturn is not peaceful. It is a colossal machine of pressure, speed, radiation, and destruction. A world with no surface to stand on, no air to breathe, no place to hide, and no mercy for anything that gets too close. It spins so fast that it physically deforms itself. It is not a clean sphere like the pictures make it seem. Saturn is flattened at the poles and bulging at the equator, stretched by its own rotation into a shape that feels almost unnatural. This is not a planet resting in the dark. This is a system under tension. And the deeper we look, the worse it gets. The rings are not jewelry. They are a hazard field. From Earth, Saturn's rings look smooth and serene, like solid bands of light, like something crafted, polished, almost sacred. But if you actually flew into them, the illusion would end instantly. The rings are not solid. They are a vast, chaotic debris field made of ice and rock fragments, moving at tremendous speeds. Some particles are tiny like dust. Others are the size of houses. Some are as large as mountains. Everything is moving. Everything is colliding. Everything is grinding. The rings stretch across an enormous width, but in many regions, they are shockingly thin. A giant cosmic blade made of fragments and momentum. And this is where the image of Saturn starts to crack. Because what we call beautiful may actually be the aftermath of destruction. One major idea is that Saturn's rings could be the remains of a moon or icy body that drifted too close, crossed a gravitational boundary, and was torn apart, not gently broken, destroyed. Shredded into fragments by tidal forces so extreme that a world could become a ring. So when we admire Saturn's crown, what are we really looking at? A masterpiece of gravity? Or a planetary graveyard arranged into something beautiful? If you could see Saturn with your own eyes from close range, would the rings feel beautiful or terrifying? Saturn's atmosphere is a place where survival stops existing. Saturn is a gas giant, which means there is no solid ground to land on the way we imagine landing on a planet. No rocky plains, no mountain base, no stable platform. If you tried to descend into Saturn, you would pass through clouds, and deeper cloud layers, then denser and denser atmosphere under crushing pressure. The deeper you go, the more the planet becomes a trap. Winds on Saturn can reach extreme speeds, racing through the atmosphere with enough force to shred weather systems and reshape entire cloud bands. Storms do not simply pass. They evolve, merge, and feed on energy rising from deep inside the planet. And Saturn has a lot of internal energy. It radiates more heat than it receives from the sun. That means this world is not just reflecting sunlight. It is active from within. Think about that for a second. Saturn sits far from the sun in the cold outer solar system. And yet, it still powers giant atmospheric violence from internal heat. This is not a passive object. It is a dynamic engine. And if a probe, ship, or human mission somehow entered too far, pressure and heat would eventually rise to catastrophic levels. There is no heroic landing scene here. No second chance. Only descent, compression, loss. The hexagon at the North Pole shouldn't feel real, but it is. Now look at Saturn's North Pole. What you expect to see is a circular storm, a spiral, a chaotic vortex. What you actually see is a hexagon, a six-sided atmospheric structure, sitting around the pole like geometry carved into weather. Not a symbol, not an image artifact. A real, persistent planetary-scale storm pattern. It is one of the strangest things in the solar system because it looks designed, and yet it is natural. A giant geometric storm with deep atmospheric motion and a central vortex, rotating in a place where most people expected only random turbulence. Saturn keeps doing this to us. Every time we think we understand how a planet should behave, it reveals a new pattern that feels almost impossible. And then it gets worse. Because Saturn does not only produce strange storms, it produces global-scale outbursts. Roughly once every Saturnian year cycle segment, enormous storm systems can erupt, brightening large regions and disrupting the planet's visible cloud bands. Some of these events grow so large, they can wrap around huge portions of the planet. Imagine a storm system on Earth visible from space, and imagine scaling it until it feels planetary. Now imagine lightning inside it, deep convection, ammonia clouds rising, and turbulence feeding on Saturn's internal heat. This is why Saturn is so unsettling. It looks quiet from far away. But up close, it behaves like controlled chaos. Which is more disturbing to you, Saturn's giant hexagon, or the idea that a planet can hide global storms under a calm appearance? Saturn's gravity does not just hold moons, it reshapes them. Saturn is not just a planet. It is the center of a giant system of moons, rings, magnetic fields, radiation, and gravitational interactions. And gravity here is not simply a force that keeps things in orbit. It is a sculptor, a destroyer, sometimes both at once. Some moons are stretched by tidal forces. Some are heated internally because Saturn's gravity constantly flexes them. Some may have been broken apart in the past. And some may owe their geological activity to Saturn's pull. This is one of the biggest reasons Saturn is so scientifically important. Because around this violent planet, we find worlds that are not dead. We find moons with chemistry, moons with weather, moons with possible subsurface oceans. In other words, Saturn is frightening not only because of what it is, but because of what it creates around itself. A dangerous giant surrounded by some of the most intriguing places in the solar system. Titan looks familiar, and that makes it worse. If Saturn is the monster, Titan is the eerie mirror. Titan is one of the most extraordinary moons in the solar system. It has a thick atmosphere, clouds, rain, rivers, lakes. At first glance, this sounds almost comforting, almost Earth-like. But Titan is not Earth-like in the way your instincts want it to be. Its lakes and seas are not made of liquid water. They are made primarily of liquid methane and ethane, hydrocarbon liquids. Its weather cycle is not a water cycle like ours. It is a methane cycle. Its surface is bitterly cold. So cold that the chemistry and behavior of materials become alien to everyday experience. Titan is fascinating because it feels like a parallel version of home built from the wrong ingredients. It has landscapes that look familiar and chemistry that feels deeply unfamiliar. This is one of Saturn's darkest tricks. It gives you something that looks almost habitable, then reminds you that resemblance is not safety. Still, Titan matters enormously, because chemistry this rich, atmosphere this dense, and a world this complex force us to ask a bigger question. What counts as interesting in the search for life? Only Earth-like worlds? Or worlds where chemistry can evolve in ways we do not fully understand yet? Enceladus may be one of the most important places in the solar system. And then there is Enceladus. Small, bright, icy, easy to underestimate. For a long time, it looked like just another frozen moon. Then we saw the fractures near its south pole. And then we saw the plumes. Water vapor and icy particles blasting into space from beneath the surface. That changed everything, because plumes mean activity. Activity means energy. And energy plus water plus chemistry is exactly the combination that makes scientists pay attention. Beneath Enceladus's ice shell, evidence points to a global subsurface ocean. Not a frozen relic, an active ocean world. And this is where Saturn becomes truly frightening in a different way. We came expecting a gas giant with rings. We found a system that may contain environments where biology could, in principle, have a chance. Not sunlight-drenched forests, not blue oceans and beaches, but dark, pressurized, hidden water in a moon warmed by tidal forces. Life does not need beauty. It needs conditions. And Saturn's system may have more of those conditions than we once imagined. If you had to choose one place to search first for alien microbes, Titan or Enceladus? Cassini did not visit Saturn. It changed how we see it. Everything we are saying here became sharper because of one mission. Cassini. For years, Cassini transformed Saturn from a distant icon into a real, active system. It watched storms, mapped rings, studied moons, captured details we could not have imagined before the mission arrived. And in the end, it made one of the most dramatic exits in space exploration. To protect moons like Enceladus and Titan from contamination, the spacecraft was sent into Saturn's atmosphere in a controlled final dive. A deliberate ending. Cassini kept transmitting as long as it could, sending data while descending into a planet that would eventually destroy it. Heat increased. Pressure increased. The mission ended inside the world it had spent years revealing. There is something haunting about that. Our machine crossed into the very thing we feared to understand it better. Saturn didn't care. But we learned. And what we learned was not, Saturn is pretty. What we learned was, Saturn is a violent system hiding extraordinary complexity behind elegance. Even Saturn's beauty is temporary. Saturn feels eternal. But it is not. Its rings are not permanent decorations. Over long timescales, material is lost. Particles fall inward. The structure changes. In cosmic terms, even Saturn's most iconic feature may be temporary. Think about what that means. The image of Saturn that defines beauty in the solar system may be a phase, a moment, a temporary arrangement of gravity, debris, time, and motion. We are alive at the right time to see it. That makes Saturn even more unsettling, because it is both terrifying and fragile, violent and temporary, beautiful and dangerous. A planet that looks like peace and behaves like chaos. The real reason Saturn feels scary. Saturn is not the scariest planet because it is ugly. It is the scariest because it is magnificent. It pulls you in with symmetry. It disarms you with elegance. It becomes familiar in pictures. And then science reveals what is really there. A crushing atmosphere, extreme winds, relentless storms, a geometric polar nightmare, gravitational destruction, toxic moons that mimic Earth, hidden oceans that may change the search for life. Saturn is a reminder that the universe does not owe us comfort. Sometimes the most beautiful thing in the sky is also the one most capable of destroying everything that gets too close. So yes, Saturn is stunning, but it is not peaceful. It is a warning wrapped in gold. And maybe that is why we cannot stop looking at it. Before you go, answer this in the comments. What makes a world truly frightening? What can kill you instantly? Or what looks beautiful enough to make you forget the danger? mystery you can't unsee. Let's start with something that should not happen. Take a few grains of pollen, suspend them in water, place them under a microscope. They jitter, they twitch, they change direction violently, as if something invisible is pushing them, almost like they're alive. Now repeat the same experiment with finely ground rock dust. No biology, no metabolism, no life. And yet, the same motion appears. So here is the first uncomfortable question. If lifeless matter moves like it's alive, what exactly is doing the pushing? And the second question is even worse. If the cause is invisible, how do we know it's real and not just a convenient story? Because this single phenomenon doesn't just raise curiosity. It challenges one of the deepest assumptions in science. Do atoms actually exist? Or are they simply the most successful fiction ever created? The motion that refused to behave. This strange jittering motion deeply disturbed scientists when it was first studied seriously. It was real, it was repeatable, and it stubbornly refused to behave. Every obvious explanation failed. Tiny currents? Eliminated. Temperature gradients? Controlled. Vibrations? Removed. Optical illusion? Ruled out. And still, the motion remained. But patterns began to emerge. Smaller particles jittered more violently than larger ones. Higher temperatures increased the agitation. Lower viscosity fluids made the motion stronger. Every trend pointed in the same direction. Not toward life, not toward biology, but toward the microscopic, toward something unseen. The idea slowly formed that suspended particles were being struck by invisible constituents of the fluid itself. But at the time, this explanation carried a dangerous assumption that atoms were real, and that was far from settled. The 2,000-year argument nobody could end. For more than 2,000 years, humanity argued about the nature of matter. Some claimed matter must be made of indivisible units. Others insisted matter was continuous, infinitely divisible. And for centuries, the continuous view dominated. Even in the 19th century, critics still argued, atoms are not real objects. They are mathematical tools, useful approximations. And here's the uncomfortable part. A model that works is not automatically true. Prediction is not proof. So the debate persisted until something extraordinary happened. A visible object began responding to an invisible world. And for the first time, reality could be forced to answer. The key shift: stop predicting paths. Here's the problem with Brownian motion. Watch a single particle and you see pure chaos. No pattern, no repetition, no predictability. Every trajectory is different. And that tempts us to say, there is no law here. But randomness does not mean lawlessness. The breakthrough came when scientists stopped asking about individual paths and started asking about statistics. Imagine a simple experiment. You stand on a straight road. Every second, you flip a coin. Heads, you step forward. Tails, you step backward. No memory, no strategy, pure chance. This is called a random walk. And it captures the statistical essence of Brownian motion. Because a particle in a fluid is doing the same thing, taking countless tiny random steps due to invisible collisions. Order emerging from noise. Now imagine not one walker, but hundreds, all starting at the same point, all following the same rules. Some drift left, some drift right. Instead of tracking individuals, we track the population. We divide space into bins. We count how many walkers end up in each region. A distribution emerges. Two features stand out immediately. First, it is symmetric around zero. Forward and backward steps cancel on average, which means the average position stays centered, even while everything moves. But here's the key insight. The physics is not in the average. The physics is in the spread. So we square the displacement for moving direction and average it. And something remarkable appears. The mean squared displacement grows linearly with the number of steps. And since steps scale with time, we arrive at a law. This is not philosophy. This is measurement. But one question remains. What determines D? The trapdoor into the atomic world. A descriptive law is not enough. If atoms are real, the diffusion coefficient must depend on measurable properties. Temperature, viscosity, particle size, and here's the clever move. Introduce an external force, not to measure it, but to create equilibrium. Two competing effects appear. A drift current pushing particles with the force, a diffusion current smoothing out concentration differences. In equilibrium, they must cancel. This balance becomes the hinge of the entire argument. Drift versus diffusion. A particle in a viscous fluid accelerates only briefly. Drag quickly balances the applied force. At terminal speed, the forces are equal. As a particle moves through a viscous fluid, it experiences drag. At terminal speed, the applied force is exactly balanced. From this, drift velocity emerges. Diffusion flows down concentration gradients. When drift and diffusion cancel, the external force disappears from the final result. And what remains is extraordinary. The diffusion coefficient expressed purely in terms of measurable quantities. Counting the invisible. Now everything snaps into place. Mean squared displacement equals 2d times time. D is expressed in lab measurements. Only one unknown remains. A number so large feels unreal. But it is not a guess. Not a fit, it is a count. a conversion factor between the visible and invisible worlds. Atoms were no longer optional. They were unavoidable. And yet, we never saw an atom, we saw its shadow. So ask yourself, is that proof of reality? Or proof of the power of models? At what point does prediction turn into belief? And how many things today do we call real? Only because we no longer know how to doubt them? Brownian motion looks like chaos. But inside that chaos is structure. And that structure forced science to admit something it resisted for centuries. If this kind of deep, honest exploration matters to you, please like the video and subscribe. It genuinely helps this channel grow. And one last question. Do we know atoms exist? Or have we simply built the most convincing explanation we've ever had?